All right, these are the notes for compound events. So we've been talking a lot about very basic probability. We've been talking about experimental probability and theoretical probability, and that's the probability of one event. Now, compound events are two events. So imagine like a compound word. If I take base and ball and put them together, baseball is a compound word. Same thing with a compound event. I'm taking one event, a second event, and putting them together to make a compound event. So sometimes with compound events, we need to come up with tree diagrams and sample spaces and all sorts of fun little things. So I'm actually going to skip sample space for a second. I'm going to talk about a tree diagram. So we've kind of already done a tree diagram. We did them the other day when we were making this foldable. So this would be an example of a tree diagram. So a tree diagram is a way of figuring out the sample space of an event. And then a sample space is a list of all possible outcomes of a compound event. So it's the list of all possible outcomes of a compound event. So we're going to start with some pretty basic ones on the front side, and we'll do a few that are a little more complicated on the back. So tree diagrams, the table below, or right here, shows the sandwich choices for picnic. How many possible outcomes are there? Use a tree diagram to create a sample space. So we're actually going to answer this first question. How many possible outcomes are there? We can use the fundamental counting principle that we learned about with this folder in order to figure out how many possible outcomes there are. So I would say, okay, there's 2 types of meat for my sandwiches, and there's 3 types of bread. So 2 times 3 says there's 6. I know there's 6 possible outcomes of sandwich combinations I can make with 2 types of meat and 3 types of bread. So let's create a tree diagram so that we can figure out our sample space or a list of all the different possible outcomes. So I'm going to say, all right, I need bread on my sandwich. Okay, and bread, I have 3 choices, and I'm just going to abbreviate them. I have rye, sourdough, and white. So I take my 3 types of bread and I put them down. And I could have started with meat. It doesn't matter. Okay, then after my bread, I'm going to pick up my meat. And my meat, I have 2 choices. So what I'm going to do is I'm going to make 2 branches off rye, and I'm going to say ham or turkey. Okay, and I'm going to do the same thing with my sourdough, ham, and turkey. And I'm going to do the same thing with my white bread, ham or turkey. Now, if there were more things we were putting on our sandwiches, then we could have had even more things. Like we could have had condiments, mayonnaise or mustard. We could have had lettuce, tomatoes, and pickles. So there's more and more that we could add to it. But we had a very basic tree diagram. This tree diagram helps us organize our information so that we can easily write a sample space. So remember, a sample space is a list of all the possible outcomes of a compound event. So I read my tree diagram like this. I start with one tree trunk and I follow the branches out. So it says a rye with ham, rye bread with turkey. Now I switch trees. Now it's sourdough on ham or sourdough with turkey, or white bread with ham or white bread with turkey. And here's our 1, 2, 3, 4, 5, 6 different possible outcomes. So it matches. I could ask a question like, what's the probability that I'm going to pick a ham sandwich on white bread? And I would look through here and I'd say, oh, there's only one of them that says a ham sandwich on white bread. So I would say 1 out of 6. Now, you don't need to have a tree diagram and a sample space to figure that out. You can figure out compound probability by using multiplication. And here's how. I would say ham is 1 out of the 2 choices of meat times white is 1 out of the 3 types of bread. So the probability I'm going to choose ham on white is 1/2 times 1/3 equals 1/6, and see how that matches. So if you're figuring compound probability out, two separate events happening, you multiply the probability of each event occurring. So let's try this idea down here. So I have a coin that I'm going to toss twice. So here's my first toss. When I toss my coin the first time, I can either get heads or tails. Okay, so your first one is always like the trunk of your tree. And now we're going to make branches coming off. My second event is my second toss. And my second toss, I can get one of two things. I can get either heads or tails. And then whatever my two branches are for that trunk, it's the same for the other one. So I can get heads or tails. So I know my possible outcomes or my sample spaces. I could get heads and then heads, heads and then heads. I could get heads and then tails. I could get tails and then heads. Or I could get tails and then tails. I have 4 possible outcomes. Let's try it over here. A pair of brown or black sandals are available in sizes 7, 8, or 9. So I'm going to start with the color. And since they're both B, I can't just use B. So I'm going to say BR for brown and BL for black. And I'm going to do the sizes. So I have 3 different sizes. They come in 7, 8, or 9. So I drew 3 branches coming off my brown. And now I've got to draw 3 branches coming off my black. So whatever I did to one, I have to do to the other. So again, this is my tree diagram. And now I'm going to create my sample space based off my tree diagram. So my sample space is saying, okay, I could have brown in a size 7. I could have brown in a size 8. I could have brown in a size 9. Okay, I'm done with the brown tree. Now I'm going to go to the black tree. I could have black in a size 7. I could have black in a size 8. Or I could have black in a size 9. Here's my sample space. And then to figure out the total number of outcomes, I could do it a couple different ways. I could count how many are in my sample space, or I could say 2 colors times 3 sizes equals 6. So there's 6 possible outcomes. So for this one, I'll read it, but then I want you to pause it and try it on your own, and then we'll see if you got it right. So it says the animal shelter has both male and female Labrador retrievers in yellow, brown, or black. There is equal number of each kind. What is the probability of choosing a female yellow Labrador retriever? Show your work in the space below, sample space. So here I want you to draw a tree and create a sample space. And then I want you to answer the question, what's the probability of choosing a female yellow Labrador retriever? So pause me now. All right, guys, so let's see what this looked like. So I could have chosen male or female, and then I have my colors going off, yellow, brown, or black, yellow, brown, or black. Or you could have reversed it. Some people I saw did yellow, brown, and black, and then only had 2 branches coming off of each of them that said male and female. Either way would be correct. The order is not specific. So when we do that, we create our sample space here. I could get a male that's yellow, a male that's brown, a male that's black, or a female that's yellow, a female that's brown, or a female that's black. That's 6 total possibilities. The question is, how many of them show a yellow female? There's only 1 out of the 6 that show a yellow female. And again, I could do that with multiplication. I don't have to draw this every time I answer a compound event question. I can use the simple multiplication. I could say a female is 1 out of 2 genders, and the yellow is 1 out of 3 color labs. 1/2 times 1/3 equals 1/6. So now they're going to get a little more complicated because now we're going to add a little bit more strands to our tree, more branches to our tree. So it says, Mr. and Mrs. Romero are expecting triplets. Suppose the chance of each child being a boy is 50% and a girl is 50%. Find the probability of each event. So they're going to have 3 babies. That's what triplets mean. So I have baby number 1, baby number 2, and baby number 3. And I'm just going to go ahead and list what could happen. So for baby number 1, there could be a boy or a girl. And then from there, I'm going to branch 2 off of each tree, because baby number 2 could be one of 2 things also. Baby number 2 could also be a boy or a girl. Okay. And then baby number 3 could also be a boy or a girl. So each branch above then has to be split into 2 more branches. That's going to say boy and girl, boy and a girl, boy and a girl, boy and a girl. So we can figure out how many different combinations of boy, girl there can be. So I'm going to use my tree. I could have a boy, a boy, a boy. They could have a boy, and a girl. They could have a boy, a girl, and a boy. They could have a boy, a girl, and a girl. Or, now we're done with that tree, we're going to use this tree. We could have a girl, a boy, and a boy. They could have a girl, and a girl. They could have a girl, and then a boy. Or a girl, and then another girl. So here's all of our possible outcomes listed out, and I see that there's 8 of them. So if I count them, there's 8, or I could have said, baby number 1 had 2 options, a boy or a girl. Baby number 2 could have been either a boy or a girl. Baby number 3 could have been a boy or a girl, and if I multiply them together, again, I get 8. So I know the denominator for all my probabilities is going to be 8. So then I read the question. Probability, all 3 children will be boys. So I come over here to my sample space and find how many times that BBB comes up all the way across. That only happens 1 out of the 8 different ways. So there's a 1 in 8 chance that all 3 babies will be boys. What's the probability of at least 1 boy and 1 girl? Meaning any combination of boy and girl, just that they're not all boys and all girls. So I see 1, 2, 3, 4, 5, 6. 6 out of the 8 different possibilities have a boy and a girl in it. Or 3 out of 4. What's the probability of 2 boys and 1 girl in any particular order? 2 boys and 1 girl. So let's see. Here's a BB and a G. Here's a BGB, so 2 boys and a girl. Here's 2 boys and a girl. And I think that's it. So there were 3 out of the 8 possibilities led us to 2 boys and 1 girl. And finally, at least 2 girls. So 2 or more G's. So let's see, we have this one. We have this one. We have this one. And then this one has 3 G's, so 2 or more. So that would be 4 out of 8. Or a 1.5, 1 out of 2 shot of having at least 2 girls. So we're going to try one more, and this is Jane, who wants to go to Mr. Freeze. And they offer their ice cream in either a cup or a cone. This week they have strawberry, vanilla, and chocolate ice cream to choose from. You can also choose sprinkles, crunch coat, or whipped cream for a topping. Answer each question below. So whenever we make a tree diagram, it assumes that one event can occur. I'm totally aware we could go to Mr. Freeze and get a cup of twist chocolate and vanilla with sprinkles, crunch coat, and whipped topping, all of that all together. But we're choosing one of each event occurring. So when we do this, I'm going to say container. I guess we'll call the first thing a container. So there's 2 container options. We can either have it in a cup or a cone. And don't write too big because this tree is rather long, so save yourself some room. So our container can either be a cup or a cone. And then I have flavors of ice cream. That's going to come next. And I look, and there's 3 flavors, strawberry, vanilla, and chocolate, which means each of these get 3 branches. Strawberry, vanilla, and chocolate. And if I did that for cup, I also have to do the same 3 branches for cone. Strawberry, vanilla, chocolate. Then I have toppings. And for toppings, we have 3 different toppings also. It says we have sprinkles, crunch coat, and whipped cream. So each of these are then going to have 3 more. So be careful that you save yourself some room. This can get rather big. So I can have sprinkles, crunch coat, or whipped topping. Sprinkles, crunch coat, whipped topping. So each of them will have a S, a C, and a W. There we go. So there's our tree diagram. And that tree diagram is going to help us make our list of possible outcomes. But let's first see how many possible outcomes there are. We can answer this question now. So there's 2 containers, there's 3 flavors, and there's 3 different types of toppings. So if I multiply those together, it'll tell me how many possible outcomes there are. So let's see, 2 times 3 is 6, and 6 times 3 is 18. So there's 18 possible outcomes. That means when I go to list my tree, there's 18 things that I'm going to list. And it's long, and it's tedious, and it's a pain in the butt, but we have to be able to do it. So we start up with this first tree, the cup tree, and we follow our branches down. Now, what I would suggest, because this is an even longer tree, is when you get to the bottom of a tree, cross it off so you kind of know where you left off. So I could have a cup of strawberry with sprinkles, or I could have a cup with strawberry and crunch coat, or I could have a cup with strawberry and whipped cream, or also I could have a cup with vanilla and sprinkles, or a cup with vanilla and crunch coat, or a cup with vanilla and whipped cream. Or I could have a cup with chocolate and sprinkles, or a cup with chocolate and crunch coat, or a cup with chocolate and whipped cream. And I've only used 1 tree, and now I got to do that same thing with my cone tree. So we're halfway done. Let's keep going. So we got a cone with strawberry and sprinkles, a cone with strawberry and crunch coat, a cone with strawberry and whipped cream, a cone with vanilla and sprinkles, a cone with vanilla and crunch coat, a cone with vanilla and whipped cream. Almost there. Then we have a cone with chocolate and sprinkles, and we have a cone with chocolate and crunch coat, and then we have a cone with chocolate and whipped cream. I fit that in barely. So here's my sample space. It's the list of all the different outcomes. What a pain. But if the question asks you to make a sample space, that's what you would have to do. Create the tree to help you organize your sample space. If I asked you to come up with all 18 of those combinations on your own without a tree, it would be really, really hard for you to do. So that tree just helps you organize your information. Okay, now let's answer the last 2 questions. How many possibilities can Jane get with chocolate ice cream? So there's a couple different ways you could do it. You could use your sample space. Remember, chocolate or flavors is what was in the middle, so I can find anything that has a C in the middle. Okay, so I see 6 of them. And since it's just asking how many possibilities, I'm just going to write 6. I don't have to write it as a fraction. I could have also gone up here and said, okay, cup or a cone, it doesn't matter, but the flavor was chocolate, and then said 1, 2, 3, 4, 5, 6. 6 possibilities. Now, this one's asking for a probability, so now I definitely need to use a fraction. So what is the probability Jane will get a cone?
Sorry for the interruption, but just to remind.
Okay, finally, this is a probability. So what's the probability Jane will get a cone and sprinkles? So if I'm using my list, I'm going to cover up the cup ones because those don't even matter. And sprinkles was the last thing on the list, toppings was. So anything that ends with an S. So here's one, here's one, here's one. So a cone with sprinkles, that's 3 out of the 18 different possibilities, or a 1 in 6 shot. Could have also used my tree. Here's cone. So I could ignore this part of my tree. Sprinkles, sprinkles, sprinkles. Or if I didn't want to have a tree, if it didn't ask me to show my sample space, remember, a cone is 1 out of 2 possibilities, and sprinkles is 1 out of 3 different topping choices, and 1/2 times 1/3 is 1/6. Hopefully this makes sense. There's a compound probability maze that it's a little challenging. You gotta know your math vocabulary. And on the back, there's an example problem where you have to make a tree a sample space and then answer a few questions. Try your best. If you need help, let me know.